The disc tray holes are all reinforced with metal. Could you please take a look at how the casing is made to prevent this metal from being trapped? A friend posted 2 photos with the question, the disc tray holes are all reinforced with metal. Could you please tell me how to prevent this during the casing manufacturing process? This is actually a very simple casting defect, and its cause is also quite simple. However, you might not be able to figure it out without careful analysis. But if you regularly read my WeChat official account, analyzing the cause of such defects will be very easy, so please follow my WeChat official account. Let's take a closer look at Figure 1 and observe the location of the clamped iron in the casting. Generally speaking, the distribution of casting defects can indicate whether the defects are accidental or inevitable. If the distribution of casting defects is irregular, like something scattered haphazardly, then its cause is likely accidental, and such causes are generally difficult to detect. However, most casting defects follow a pattern, meaning they are caused by inevitable reasons. In this case, we need to look for hidden patterns in the distribution of casting defects. Let's get back to the casting we're discussing. If you observe Figure 1 carefully, and you can zoom in, you'll find that the location of the clamped iron defect is basically in the middle of the casting. The issue of core jamming at the hole location is essentially twofold. One is that the wet strength of the core at the hole location is low, leading to poor high-temperature strength of the casting. The other is that the core at this location is subjected to external impact, causing the core to break and resulting in core jamming. Let's return to the IGN of the casting's gating system, as shown in Figure 2. Observe the molten metal flow trajectory. The molten metal flows directly down from the riser, enters 2 auxiliary sprues, and then directly into the casting cavity. Due to gravity casting, the molten metal rushes along the auxiliary sprues towards the center of the casting, impacting the core in the middle. Furthermore, the casting pressure head is considerable, and the velocity of the molten metal increases under gravity, thus the impact on the core in the center of the casting is even greater, making core breakage illogical. We analyzed the causes of this defect in the butterfly plate sandwiching iron. The primary responsibility lies with the technical personnel. The designed gating system violated a major taboo in casting process design. The in-gate directly faces the core. While the impact causing core breakage is secondary, the resulting overheating and shrinkage cavities are far more serious. A secondary responsibility is the slightly inferior shell quality. However, if we were to translate this into concrete figures, technical issues account for 95%, while shell quality accounts for at most 3%.